Hello, in today's video we're going to be discussing the idea of limiting reactants. Now, the limiting reactants is a more realistic way of doing the stoichiometry that we've been doing in class. So what we've been doing in class is, let's say we have a reactant A, and we're going to react that with reactant B. That's going to produce C. So two reactants producing one product. This is a type of reaction. What we've been doing in class is, let's say we have a limited amount of A, we will have had an excess of B. So much B that is not taken into account when we're figuring out how much product can be made. Well, this isn't really what happens in the real world. In the real world, you'll go down to the laboratory, you'll weigh out A, you'll weigh out B, you'll mix them together, and then one of them is going to run out first. And the one that runs out first is called the limiting reactant. So we're going to be identifying how these types of reactions work. Now, it's kind of difficult to understand the concept of limiting reactants in the world of chemistry because you're not yet chemists. So let's do an example that's not related to chemistry, but the concept is still a limiting reactant type of problem. So let's say we want to make a bicycle. Okay? We're in the bicycle making business, and to make a bike we have a frame, we have two wheels, and we have a handlebar. So for this type of a procedure, we're going to have three different reactants. We're going to have the handlebar. We're going to have the frame, which is the triangle, frame. And then we're going to have two wheels per bike. So let's say that we bought a certain amount of each one of these. Let's say that we have 8 wheels. That might look like oxygen, so let's make this wheels. Let's say that we have 3 frames, and let's say that we have 5 handlebars. And let's see how many of these bicycles can totally be made. Well, this is the same type of system that we would be using if we were in chemistry course. We know that for every bicycle, it requires one frame. So we're going to write our chemical reaction. Frame plus handlebar plus 2 wheels equals a bike. Okay. So this is our chemical reaction. 1 frame, 1 handlebar, and 2 wheels equals 1 bike. This is a conversion factor just like you would see these will create conversion factors just like you would see in a chemical reaction. So let's see exactly how many bicycles we can make with each one of these reactants. We now have a reaction that has 3 different reactants. For 8 wheels, we know that for a bicycle there are 2 wheels per every 1 bike. So now we can make 4 total bikes if we had 8 wheels. For frames, we know for every 1 frame, there's 1 bike. We can make 3 bikes. And for every 1 handlebar, there's 1 bike, so we can make 5 bikes. So what we did was we took each of the reactants, the starting amount of each of the reactants, which in this case happened to be handlebars, frames, and wheels, and we converted them over to the total product, which is going to be a bicycle. We're trying to make a bicycle. And we use the conversion factors that we got from a balanced equation, just like we would in chemistry. What we can see here is if we had 8 wheels, 3 frames, and 5 handlebars, the total amount of complete bikes that we can make is 3. Because once we hit 3 bikes, we have run out of frames. So what that means is the frames is called our limiting reactant. So this is your limiting reactant. Limiting reactant. And everything else is going to be considered in excess. So the wheels and the handlebars are considered to be in excess. So since the frames ran out first, it limits the amount of products that we can make, which in this case is bicycles. It is called the limiting reactant. Okay. Now, when we're talking about this in terms of chemistry, you can do the same type of procedure. You can have a balanced chemical equation. It gives you the stoichiometric relationships. You can convert each of the reactants, the starting amounts of each of the reactants, to a single product, and then you can compare exactly which one runs out first. And the one that runs out first is going to be called your limiting reactant. The other ones, if there are multiple, they're going to be called your excess reactant. Now with this idea, I know this isn't in the terms of chemistry, but the procedure is the same as what we would do if we were a chemist. So in class tomorrow, we'll start working on limiting reactant problems, which is more realistic and is a very standard type of chemical practice. So with that, I want to say have a great night. I'll see you all in class tomorrow.